your notes pulled up for 7-1 day 4. I get to show you something brand new. It's called, it looks like Euler, but his name is pronounced Euler. So I get to show you Euler's method. And here's the type of problem that Euler is going to help us solve. So keep in mind when I did slope fields with you, I gave you a differential equation, similar to something like this, and said, okay, so yeah, we can't figure out what y equals, but we can at least see like the shape of the graph by making a direction field. So we were able to see the shape of the graph. Well, here's what Euler allows us to do. If we know the slope, aka the derivative, and if we know a point on the function, I have to have somewhere to start. If I know a point on the function, then I can figure out, using Euler's method, another point on the function. And you're going to be able to see by the process that we use, you're going to hope that the point we want to figure out isn't too far from the point that they give us. So we only have to go from x equals 2 to x equals 3 on this, which you're gonna realize, whew, I'm glad they didn't ask for like the y value when x was 5, because that would have taken some work. So I've taken this information and I've put it on my graph. So here's what I have. I have some blue function. I don't know what it is. I don't care what it is. I know this ordered pair on the blue function. I want to know this ordered pair, which is close to the blue function, okay? I want to know what f of 3 is, and we're gonna get kind of there. And here's what else I know. I know the slope of the tangent of the function everywhere. So before we get started, I just want to remind you that the derivative means slope of the tangent. There are several ways to write the derivative. You can also write y prime. You can write it dy dx. Yes? Which also means the change in y over the change in x, right? dy is also delta y, dx is also delta x. So anytime you see this, it represents this, the change in y over the change in x. So what we're going to do is we're going to start with the point 2, 0. We're going to use the slope at 2. The what at 2? The slope at 2. The change in y over the change in x. We're going to figure out how much did x change, how much did y change, what's my new point. And then we're going to figure out the slope at your new point. Because you know what slope represents? Slope represents change in y over change in x. That's going to get us a new point. We're going to do the slope at that point. Because you know what that represents? Change in y over change in x. And so on until we get up to here. Okay, so let me, and you all are free to write in your notes as I'm doing this. Come on. There we go. I'm going to get rid of this stuff. You're free to write in your notes as I'm doing this. I'm also going this is going to help you understand what we're doing, and then I'll show you a quick way to just make a table and get it done. You still have to do all of the calculations, and you're going to need a calculator. But it'll be better than going, you know, along the graph step by step. Okay, so just watch for a while. So I've got this. Okay, so here's what I want to do. I want to start by finding y prime. I think I'm going to write it up here. There we go. That's so I don't forget it. I want to find y prime at 2. So I'm going to go y prime at 2 equals Now remember, this is the ordered pair 2 comma 0. So y prime at 2 is going to be 2 plus 0, which is 2. You know what that means? That means dy dx is equal to 2. That means 2 is equal to my change in y over my change in x. Look at how much x changed. This is delta x. This is 0.2. Let's figure out how much y changed. So I'm going to go 2 is equal to delta y over 0.2. Well, delta y must be 0.4. So, let's see. This new ordered pair, the x used to be 2, delta x was 0.2. 2.2 comma. My y was 0. It went up 0.4, so my y is 0.4. Okay? New point, new slope. So at the point 2 comma 4, y prime is equal to 2.2, 2.6. Y prime, change in y over change in x. So 2.6 has to equal the amount that x changed and the amount that y changed. Delta y over, we don't know this, we do know delta x every time is 0.2. So delta y is 5.2. No, it's not. Stupid decimals. 0.52. So new ordered pair. This one was 2.2. This is how much x changed, 2.4. This was my y. I drew that wrong. Hold on. Delta x, delta y. Ah, much better. Yeah, my delta y only starts from where this one left off. It's not the whole thing like I originally drew. That was silly. So from this point, this is my change in x, which was the same. This is my change in y, okay? So from here to here, it went up 0.52. So from 0.4 up 0.52 gives me 0.92. And I would do it again. I would get the slope here. Y prime equals x plus y. I'm going to need a calculator here pretty soon. .32. So 3.32 needs to represent the change in y over the change in x. And I get the change in y is 0.664. So that is 0.2. That is 0.664. My new ordered pair is 2.6 comma. And then we were at 0.92 for y, and we need to go up that amount. 0.92 plus 0.664, 1.584. 1.584. Slope, y prime equals 2.6 plus 1.584 is 4.184. 4.184 is supposed to represent change in y over change in x. Times 0.2, 0.8368. That means this went over, oh, we're almost there. 0.2 up 0.8368. So then my new ordered pair is 2.8 comma. The old y value plus the change in y. 2.4208. 2.4208. We're almost there. Last one. Y prime equals, add those together, 5.2208. That's change in y over change in x. 5.2208 equals change in y over change in x, which we know is 0.2. Times 0.2. So y went up 1.04416. That's how much it went up. It went up from here, 2.4208. My new y value looks like it should be 3. I'll round my final answer to 3 decimal places. 465. 465. There we go. So each time we're using a new ordered pair, we're finding our slope, we're remembering slope represents change in y over change in x. We know what our change in x was every time. So we went from 2 to 3 with an increment of 0.2 every single time. Okay, so that is a mess. Let me show you how I would do this without doing it along a graph every single time, and I think you're going to like this way better. I make a table. So in my table, what I'll do is I'll make an ordered pair. I'll figure out what y prime is for each ordered pair. And then I'll break that down to delta x, which is totally easy. We know delta x every time. I'll use that to help me find delta y. That's a little bit harder. And then I'll have my new ordered pair. Okay, so let me do, I don't know, let me do maybe a few of these in our table. We started with the point 2, 0. Just a reminder, y prime is equal to x plus y. So in this case, y prime was 2. Change in x every single time. is 0.2. That's our increment. Change in y. Here's where you need to do some math. Remember your derivative, dy dx. This represents change in y over change in x. So I'm going to go 2 is equal to delta y over 0.2. So my answer for this column is 0.4. And then to figure out your new point, here's your old point. Move it this much for your x, move it this much for your y. And you can rewrite it if you want to. New point, new y prime. Same delta x. New y prime equals delta y over 0.2. Let that help you figure out your delta y. And then, old point, put your change in x on it, put your change in y on it, write your new point. And so on. And so on, and so on, and so on, until you hit 3 comma answer. Okay? So if you can, hopefully this helps you understand what we're doing, seeing it go by increments. Oh, and also keep in mind, I didn't get the true y value for f of 3. How would I have gotten a better y value? I could have used increments of 0.1. 0.01 if I had no life, right? But I chose to only use 5 increments of 0.2. So it's kind of like doing the rectangular approximation using, using the rectangles. The more you use, the better estimate you'll have. Okay.